All right, hey you guys, how's it going? Today is Monday, October 12th, and we have officially reversed roles here. I'm over my quarantine. I'm able to be back at school now, so I'll be working from school for this week, and you guys will be working from home. So, like I said, we officially switched spots, switched roles. Hopefully, we don't run into any snags. We do have a few days under our belt already from last week, so I think our transition will be pretty easy. I don't see us having too much of a struggle with the whole remote learning stuff. So yeah, hopefully you guys don't have any connectivity issues or anything like that, but just kind of be aware of the fact that I am at school. So if at any point throughout the week you do run into questions, I will be definitely available to answer those questions. You can email me and I can email you back. That's typically the easiest way to get questions resolved. But I will also be available for Google Meets. So if you have questions and you want to actually have kind of an explanation, and not just kind of the the picture of the explanation, but the actual follow along, you can definitely send me an email and I'll send you an invite for a Google Meet, and we can kind of talk somewhat in person or face to face about whatever it is that we're working on. So for today, we're actually not going to get a new assignment. Today, just kind of following off of my plans from last year, my plan was to just really recap, sine, cosine, cotangent, and tangent, and make sure that we're good with that before we move on to the final cosecant and secant graphs. So you can see here, basically what I'm going to do is I'm going to use that worksheet from last week that I had you guys doing. I know I only had you in the description or the directions, I only had you doing 2 through 5. But I am going to look at a couple other ones, specifically number 8. Number 8 was a cosine curve. So this is just a kind of like almost like a wrap up discussion before we move on to cosecant and secant. So just watch this video, make sure that it makes sense. You can kind of compare it to what you have done for some of the questions from last week. All right, so you can see again, number 8 is right here, and really the purpose is to show you how sine, cosine, tangent, and cotangent, it's all the same process, right? We kind of alluded to that last week. The first thing that you do, regardless of what it is that you're focusing on, is you find the length of your period. The thing you have to remember is that for sine and cosine, the typical period, or one full period, is 2 pi radians. So you just divide whatever, you divide by whatever your coefficient in front of theta is, your coefficient in front of your angle. But again, the trig function you're graphing will determine if you're dividing 2 pi by, in this case, 4, or just pi by 4. So in this case, it's 2 pi over 4, so it's pi over 2. So basically what that tells us is, our whole curve here. Actually, I should probably just thinking ahead with my amplitude and my vertical shift here. I should probably slide my graph down just a ways here. But again, the whole purpose here is that tells us what our first 4 increments should be. So it should be pi over 2, should be one full period length in here. And then you start cutting that in half. Half of that would be pi over 4. Half of 1/4 pi is 1/8 pi. So this is pi over 8. And now to get these next tick marks, we just add an eighth. So 1/8, 2/8, 3/8, 4/8 is obviously half, 5/8, 6/8 would be 3 pi over 4, 7/8, and then obviously 8/8 is 1 pi. So first thing we do, regardless of what trig function we're graphing, is we find the length of our period, use that to map out our first 4 x coordinates, and then carry that over to our another 4 x coordinates. Okay? Once we get our period length, then we start looking at phase shift and vertical shift. Phase shift is the opposite of this constant, which in this case is a negative pi. So our phase shift becomes positive pi over whatever that same coefficient is. So in this case, it's pi over 4. So we'll talk more about this when it comes time to graph it, but that means that since this is a cosine wave, and typically a cosine wave starts at 1, right here at 0, 1, we would have to move that to the right 2 spots, because that's how far it takes to get to pi over 4. So a phase shift is just a horizontal shift of all your points. But in this case, there's also a vertical shift. So the vertical shift of 3 actually tells us we want to kind of like translate our midline. Instead of this cosine wave oscillating over the x-axis, that x-axis, it's called our midline, slides up 3 units. So I do like to do this just so we really have that midline for reference, okay? Our vertical shift slides up 3. So now, again, well, let me not mention that just yet. We do also have an amplitude adjustment of 1/2. Okay, so what you guys are going to see here, based on how I constructed my graph on this one, my actual curve is going to be really, really smushed, because an amplitude of 1/2 means that instead of a normal amplitude of 1 and this curve oscillating 1 unit above and below, now it's only going to go up 1/2 of a unit. So let's think about this for a second. The normal cosine curve starts right here at 0, 1. Okay, I need to now slide up, okay, so that I'm 1 unit above my midline. Okay, so now I'm not sure if you guys can see this, but I'm right here. But a couple different things. Number one, instead of actually going up 1/2 a unit, or excuse me, 1 whole unit, I'm only going to go up 1/2 a unit above my midline. That's the amplitude adjustment. But I also have to remember that my phase shift is going to slide every unit or every point pi/4 radians to the right, which again, on my x-axis, that's 2 units. So I need to start my cosine curve actually right here for this one. So I'm up pi/2 units, or I'm up 1/2 of a unit above my midline, and now we just kind of do what a normal cosine curve tells us to do. 1 more unit, we should be at the midline. Another unit, we should be below the midline, but again, only below it 1/2 of a unit. Another unit over, we should be back up to the midline, and then to complete this period, we should be 1/2 a unit back above. So here's one period of this cosine curve, and then to continue it over another one, we would just go, all right, so at this point I'm at 3 pi/4. I would have to go, let me make sure that 1, 2, 3, 4, 5, yep. I would be back down at 0, back below by 1/2, back above, or back, excuse me, to 0, and then back above. There would be the second period of that cosine curve. Okay, so that one was a particularly strange one, just because of the fact that, you know, there was everything. There was an amplitude adjustment, a phase shift, a vertical shift, and a periodic adjustment. But it also ended up graphing kind of weird because of the fact that the amplitude squished it so badly. Now, the big point I wanted to make to you guys in this video was just recognizing that no matter what kind of curve you're constructing here, whether it's cosine or sine or tangent or cotangent, it all just boils down to the work is the same, but you have to remember what the parent graph looked like. Like we needed to remember that the cosine parent graph starts 1 unit above the midline and then oscillates below and then back above. Okay? So the next one I want to look at is number 5. Number 5 is a tangent graph. So number 5 looks like this. Y equals negative tangent theta over 4 plus 3. And one thing that I did not put up here that I think you will notice when we get to the actual quiz down the road here is one of the things, and I guess in the directions it did ask for it. It did ask for a reflection, and obviously we would have just simply said there was none. There was no reflection for number 8. Obviously here, and it doesn't really matter, but as I look at the worksheet in front of me here, it does state, if I'm just going in order, reading the directions in order, the first thing it does ask for is there a reflection? So you could in theory just put yes, there's a negative sign in front here, so there is a reflection. But if we want to get really formal, we would say there is an x-axis or a vertical reflection over the x-axis. And I'm just kind of going along here. It does go in this order. It says find next the period. And then it does say amplitude next. I like to just put the amplitude last because amplitude's kind of the last thing that we want to think about. So I'm actually going to find phase shift, vertical shift, and then amplitude final. When we, like I said, when we get to a quiz on this, all this stuff is sort of listed for you and you just fill it in. So like you would, like I said, on number 8 where it says reflection, you would just say none. Okay, some of these are going to be none as well. All right, so our periodic adjustment here, now that this is a tan or cotangent, we don't divide 2 pi by the coefficient, we divide 1 pi by the coefficient, because the typical period for a tan or cotangent curve is only pi radians rather than 2 pi, so only 180 degrees instead of 360. So it's pi over 1/4, because this is theta over 4 is the equivalent of 1/4 theta. So it's pi divided by 1/4, which basically turns into 4 pi. So this is actually great. This is ideal for us when our periodic length is something like that, okay? Because it allows us to go just simple counting. Here's my first full period. My first 4 marks on my x-axis are 4 pi. Half of that is 2 pi. This literally means I just count by pi. 1 pi, 2 pi, 3 pi, 4 pi, 5, 6, 7, and 8 pi. 5 pi, 6 pi, 7 pi, 8 pi. Okay, doesn't change the fact though that we still need our 4 tick marks to be arranged so that they fill up our first full periodic wave, okay? There is no phase shift on this one, so we would say none. There's only a phase shift when there's a constant in parentheses with the angle. So even though there is a constant with the angle, it's not in parentheses, so it represents an actual vertical shift. So just like on number 8, that +3 represented a vertical shift, it's the same thing here. There's a vertical shift of 3. And there is no amplitude adjustment. I guess we could say none for amplitude, but that doesn't really make sense. We would just say it's got an amplitude of 1. Okay, all of these typically have an amplitude of 1 unless they have a coefficient. All right, now what it boils down to, you guys, is simply remembering what does the typical, or what does the parent graph of the tangent curve look like? The parent graph of the tangent curve is when you use 2 units to the left of the origin, so this would be in this case negative pi and negative 2 pi. What we want to remember is this: for the tangent curve, the asymptotes are at basically negative 2 units on my x-axis and positive 2 units. Okay, the tangent curve is the one where the asymptotes are at negative 2 and positive 2. And another thing worth remembering here is there's no phase shift. So those 2 asymptotes do not slide side to side. They would be at, like I said, negative 2 and positive 2. So those don't move, okay? Which means my next asymptote is going to be 4 marks away also. 1, 2, 3, 4 at 6 pi is going to be my next asymptote if I'm drawing 2 periods of this thing, okay? And then all we have to remember here is, what does the tangent curve look like? The tangent curve is the one that goes up from left to right. Typically it goes through 0, but the vertical shift of 3 means I need to slide that point up 3. So I'm up here at 3, and then what we want to remember is there's a point to the right and a point to the left. Basically those are like, if you want to think about like slope, it's up 1, right 1, put a dot there. And then it's left 1, down 1, put a dot there. So it looks like 3 dots in a row, but they don't actually go in a row, they go in a curved form where they approach both asymptotes, just like that. And then we do the same thing in between these two. Directly in between is usually going to be a dot on the x-axis on the midline, but you have to slide that up 3 because of the vertical shift. And then you go up 1, right 1, left 1, down 1, and then just construct the typical tangent curve. Okay? So again, it really boils down to remembering that with the tangent curve, the asymptotes start at negative 2 and positive 2 on the x-axis, whatever those are. In this case, it was negative 2 pi and positive 2 pi. The parent graph is negative pi over 2 and positive pi over 2. But it's all a matter of, basically, it's 2 units to the left of the origin and then 2 units to the right. That's where your asymptotes go. And then you put in your typical tangent curve, except I messed up on this one because there should have been a reflection. So, my bad. There's the negative sign here. What this actually means is that this is going to look like a cotangent curve. You'll have to excuse me. There's a reflection, so this one, like I said, is going to appear to be a cotangent curve, except it's not. It's just a reflection of the tangent curve. My bad. I almost missed that one. I'm glad I caught that before I moved on. So, again, I missed the reflection on that one. The negative sign just reflects it, makes it look like a cotangent curve. So my bad. All right, we're going to finish this discussion up. We're just going to look at one more of these. So we looked at a tangent curve, even though a tangent curve reflected looks like a cotangent curve. I do want to look at, just like I said, one more of these. Let's look at number 4. Okay, number 4 is a cotangent curve, so number 4 is going to look like number 5 to some extent. At least the curves are going to look like this. They're going to be going down from left to right because it is a true true cotangent curve. So here's what this one's going to look like. Y equals 2 cotangent theta over 2 plus pi over 8. Okay, and we'll go down, like I said, kind of in order here. So we'll start with reflection because that's what the directions ask for, but in this case there is no reflection. It's going to appear to be a true cotangent curve. Our periodic adjustment here is just pi divided by, in this case it's theta over 2, so that's 1/2. Pi divided by 1/2 is the equivalent of 2 pi. So again, it doesn't matter if this is sine, cosine, tangent, cotangent, or what you guys are going to see tomorrow, secant and cosecant. All this allows us to do, or all we really focus on here, is this allows us to come up with our first 4 tick marks. 1, 2, 3, 4 is at 2 pi. So cut that in half is pi, cut that in half, it's pi over 2. Every tick mark on our x-axis is 1/2 pi. So 1/2, 2 halves, 3 halves pi, 4 halves, 5 halves is 5 pi over 2. 6 pi over 2 would be 3 pi. 7 pi over 2, and then obviously 4 pi would be way over here. Okay. One thing that is worth remembering, I'm going to mention it now and I'll mention it again, is the cotangent curve looks like this, right? It's the curves that go down from left to right, but it's also worth remembering that the typical first period, the asymptote is the x-axis, and then 4 units away at the 2 pi. Okay, so not only do we have to remember that the tangent curve typically goes, or the parent graph of the tangent curve goes up from left to right, the tangent curve has asymptotes at -2 and +2, whereas the cotangent curve has asymptotes at 0 and 4 on our x-axis, okay? Unless there's a phase shift, so we'll talk about that right now. There is a phase shift here of negative pi over 8, because it's the opposite of this, which was plus pi over 8, divided by 1/2. So that would be negative pi over 8 times 2 over 1. The 2 and the 8 cross simplify. It's negative pi over 4. So if you think about this for a second, this is going to be particularly interesting. I'm really glad I landed on this one. Every tick mark on my x-axis is 1/2 pi. But this tells me that that asymptote that's usually right here on the y-axis has to go left pi over 4 radians. So what you're going to see on this one is all of your marks are going to be in between. My asymptotes are actually going to be at, essentially, if you want to think about it this way, negative 1/2, because that's negative pi over 4 is halfway between 0 and negative pi over 2, which means my other asymptote, instead of being 4 units over at 2 pi, it's going to be halfway in between 3 pi over 2 and 2 pi. That just basically means every other point in here is going to be in between marks, okay? Before we can put the points in, we have to find if there's a vertical shift. So in this case, there is no vertical shift. There's no constant at the end. There is an amplitude adjustment. There's an amplitude of 2, okay? So the amplitude does not affect my midpoint. My midpoint between these two asymptotes would be right here between pi over 2 and pi. But basically the amplitude affects, or you can kind of think of it as like a slope adjustment. Go up 2. Okay, so remember, this is cotangent. So cotangent, when I go up 2 units, so I'm just going to go like this. Here's 1, here's 2. When I go up 2, I go left 1. Whoops. Up to left 1 to get to right there. And then I go down to right 1 to get right there. And then I construct my typical cotangent curve. Just like that. Okay, so the amplitude again does not affect the midpoint because the midpoint stays on the midline, and the midline is still the x-axis because there's no vertical shift. But the amplitude affects the other 2 points that create the curve. All right, to create our final piece of this curve or our second period, I'd have to go 4 units to the right, draw another asymptote. So 1, 2, 3, 4 units is right in here. There's my asymptote. Directly in between those is my point on my midline. And then again, it's up 2, left 1, down 2, right 1, and then construct your typical cotangent curve because there was no reflection. Okay? So again, it's, there's a lot of stuff going on when you construct these curves, but once you get a little bit of practice behind you, and some clarification, it's really not too terribly bad. What you're going to see tomorrow is we're going to look at how you construct the cosecant and secant curves. And, again, there's kind of a long explanation behind the how, but once you get the how and once you see what the parent graph looks like, it's all just transformations and manipulations of the parent graph. Okay? So we'll be on cosecant and secant for a little while, but ultimately it's not going to be too terribly difficult, and then we will be ready to take a quiz on this or a test, whatever we want to call it, relatively soon, and then be able to move on to kind of the next, the next realm of what high school calc is all about. So no assignment for today. I'm not going to have you guys working on this anymore. If you have yet to submit the actual worksheet on cotangent and tangent graphs, again, it was just 2 through 5. Go ahead and get that submitted to me today, and then tomorrow is when you'll get your first round of homework with cosecant and secant. All right, guys, have a great Monday. I will talk to you later.